Alright, the last method we're going to use to solve systems is called elimination. So I'm going to go through some notes on how you can use elimination to solve problems. So in the previous lesson, we learned how to algebraically solve a system of equations by substitution. And then there's another common method for solving linear systems algebraically, which is called elimination. This method relies on two important properties of equality that are shown below. So if I have four numbers, a, b, c, and d, and they're any number, any real number, and if a is equal to b and c is equal to d, and I decide to add them together as I do a plus c and b plus d, they're equal, because equals added to equals still stay equal. And if you have a equal to b and you multiply both sides by the same number, or they're both being multiplied by c, the multiplied equals still form equal values. So these will make sense as we work through these problems. So let's look at elimination, exercise 1. Solve the following system of equations using elimination. So first off, how you know to use elimination is when the question is set up like this problem, where you have the variables lined up on top of each other. For graphing we did y equals mx plus b, and we had two equations like that. So that's when we used graphing. And then for substitution, we had one of the variables solved for, like y equals some number, and then we had x plus y equals something. Or it was x equals something, and then you plugged it in for x and solved from there. So that was our substitution type. Alright, so elimination is our third method. This is when the equations are lined up with x on top of each other and y on top of each other. And the benefit of elimination is if I add the two equations together, we're eliminating one of the variables. And the way you eliminate is you look for the opposite signs. So right away, if I look at the y's, they have the same coefficient, 2, but one is positive 2 and one is negative 2. Because now look what happens. If I combine these two equations, 3x plus 2x gives me 5x. 2y minus 2y, those cancel out. And then 8 plus 12 is 20. So I'm adding everything on this side and everything on this side together. Then I just divide both sides by 5, and I get x equals 4. Remember, for systems, we need to solve for two variables. So you have to solve for x and y. So now you take your x variable, and you plug it into either equation and solve for y. So I'm going to just use the first equation, which was 3x plus 2y equals 8. Here it's telling me that x equals 4, so I'm going to plug in by substituting, replacing the x with 4, and then solving for y. 3 times 4 is 12, plus 2y equals 8. Subtract 12 on both sides. 2y equals negative 4. Divide by 2. Y equals negative 2. So my solution for this problem is 4, negative 2. You can check on the other equation. 2 times 4 is 8. Negative 2 times negative 2 is positive 4. So 8 plus 4 is 12. So you know you did this right if it satisfies both equations. So again, to recap, for elimination, they should be set up with the variables lined up on top of each other, and then you're looking for a positive and a negative with the same symbol, or the same number, to be able to combine them to make them equal to 0. So let's look at the bottom set. Solve the following system of equations using elimination. So we know we're going to use elimination because the x's are on top of each other and the y's are on top of each other. Now I'm looking for the positive and negative variable, and it looks like the x has a positive x and a negative x. So here, when I add these two equations together, my x's eliminate, y plus y gives me 2y, and 6 plus 8 is 14. And now I can divide by 2, and y equals 7. Remember, we need two answers to our solution, so I plug this into either equation and solve for y. So I'm going to use the first equation, x plus y equals 6. You just told me, or we just figured out that y was 7. So I'm going to substitute in 7 for y, and then solve. Remember, you undo operations to solve. So my solution is x comma y, -1 comma 7. And if we check, the opposite of -1 is +1, plus 7 is 8. So this one is good. Let's take a look at the back problems. So given this question, which of the following is a solution to the systems of equations given to the right? So they give us 4 choices here that we're going to solve for. When I look at my 2 systems of equations, I know I'm going to do elimination because the x's are on top of each other and the y's are right on top of each other. So again, I'm looking for that one that has the variable that has an opposite sign and the same coefficient. So the y's, one has a -4, the other one has a +y. So these ones won't eliminate when I add them together. But the x's, one is positive, one is negative. So when I add them together, they're going to eliminate. So -4 plus 1 is -3, and the y stays with it because these are like terms. 16 minus 1 is 15. And if I divide by -3, y equals -5. And in a multiple choice test, when you look at your answers, there's only one possible answer that has y equal to -5, which is 3. You can prove that the x is -4 by just testing it. If I use the bottom equation this time, doesn't matter which equation you use, either equation you should get the right answer. If I plug in -5 into this equation, -x plus -5 equals -1. I would have to add 5 to both sides to undo that 5. And I would get x equals 4. Keeping the negative with my x, divide by -1, x equals -4. Okay, one more equation. Actually, three more, sorry. Solve the system using elimination. So again, we know to use elimination because the x's are on top of each other and the y's. And right away, hopefully at this point, you're able to identify that you can eliminate the y's right there. So 2x plus x is 3x. -y plus y is 0, they cancel. And 3 plus 3 is 6. Once I get that, I divide by 3 and I get x equals 2. So now I can plug in 2 into either equation and solve for y. Two times 2 is 4. Subtract 4 on both sides. -y equals -1. Divide by -1, y equals 1. So my solution is 2, 1. Plugging that in, 2 times 2 is 4, minus 1 is 3, 2 plus 1 is 3. Next problem. Solve the systems using elimination. Again, we know to use elimination because the variables are lined up, and now I can tell that the x's are the ones that are going to eliminate because they'll go away. -x plus x goes away. -6 plus -2 is -8, and there's the y's. -28 minus 4 is -32. Divide by -8, and I get y equals 4. Plug my y value into either of my equations. I'll do the second equation this time, just to show you that it doesn't matter which equation you choose. X minus 2 times 4 equals -4. X minus 8 equals -4. Plus 8 plus 8. X equals 4. So 4, 4. Alright, take a look at number 4, because here's where it gets a little bit harder. If I were to eliminate, or try to eliminate a variable in this case, just by adding, nothing would eliminate, because 3 plus -x is 2x, and 3 plus 3 would give me 6y. So the way these equations are set up currently, you cannot eliminate anything. But we can manipulate one of the equations to be able to eliminate something. And how you manipulate it is that you try to find a value that will cancel out when you add these together. So you could focus on either variable to do this problem. I'm going to focus on the x's. If I want to add 3x with the negative x and make it to equal 0, what number needs to be the coefficient of here? Well, 3 plus negative 3 would give me 0. So to do this, I would have to multiply everything in the bottom equation by 3. So that's why I'm going to put it around parentheses and multiply everything by 3. So 3 times negative x is negative 3x. 3 times 3 is 9. And then 3 times 10 is 30. So 3 times negative x is negative 3x. 3 times 3y is 9y. And 3 times 10 is 30. I just changed my second equation. It's the same variables. I just changed the coefficients by multiplying by 3. Using the other equation now, the top one, I'll just rewrite it. Now do you see when you eliminate by adding, the x's will cancel because I manipulated it. So I get 12y equals 48. And then divide by 12, y equals 4. Plugging in 4 for y into either equation, I'll use the first one. Subtract 12 on both sides. 3x equals 6. Divide by 3. X equals 2. So my solution is 2, 6. So again, when you can eliminate, you might have to manipulate one of the equations so that when you add them together, something will be eliminated. Notice, if you wanted to eliminate the y's, you could have multiplied either equation by negative 1, and that would have changed everything to a negative, and then you would have been able to add them together. So for example, let's say I took that first equation and I multiplied everything by negative 1. Everything would change its sign. Keep the bottom equation the same. And it should be negative 18. Negative 3x minus x is negative 4x. The y's cancel out. Negative 18 plus 10 is negative 8. And then divided by negative 4, I get the same answer of x equals 2. So either method, you could have gotten the correct answer. These are going to be the more challenging problems, so work on the practice problems today for class.